Hey everyone, welcome back to this Abaqus tutorial. Today we are diving into a tensile shear spot weld simulation. So as usual, we create the part first. It should be 3D, deformable, solid extrusion, and the approximate size of 300. First we create a rectangle like this. The height should be, the length of the sheet should be 100 and the length should be 30 millimeters, and that's it. This is the part we create done, and the depth should be 1 millimeter. So this is the sheet we have, but we want to create the overlap section and the spot weld as well. So here by partition face we select this one, we click the scroll button of the mouse, and vertical right we have to click this one. So we want to create the overlap region here. It should be 30 millimeters, and there should be one spot weld in the middle. Make sure to put this spot here, this tiny spot here which changes on the circle. Make sure that it should be on one of the main direction, like horizontal or vertical direction. It should be here or here. It cannot be here because it would be bothering us into the meshing section. So I click on this one. It should be 4 millimeter, and the distance to this part should be 15, and it should be 15 to here as well. So we click on the scroll button of the mouse and done. So we have one circle here which is the spot weld and one overlap section, but there's a problem here. By using this one or Control Alt and left click of the mouse, you can rotate this instant. So here we see we have one circle here, but it's not here. So we want to sweep this one and this one through the section. So we left click and hold on this one and use partition cell extrude / sweep edges. We select this one, scroll button, sweep along edge, and we use this edge, and that's it. If you see, here is extruded to the other side. So we want to do the same thing for this line. We click down, sweep along edge, and we click on this edge, and we have this part swept through the edge. So this is the part section. Now we can go to the property. Here create the property. We say steel. From general, density should be 7.85 E-9. Mechanical elasticity, elastic should be 210,000, 0.33. And for the mechanical plasticity and plastic, we want to select this one, Control C and Control V here. So we have the plastic part, and we can have the damage for ductile materials here, and we can copy and paste these values here to Abaqus. Control C, Control V, and we have this one. And for the sub options in damage evolution, we put the value of 0.44 for the displacement at failure, which explained thoroughly in the previous video, so make sure to check that. So this is the materials properties, and everything is okay. So next we should create a section. Should be section 1 homogeneous solid, and the material is just steel. Now we want to assign the section. The section is assigned here. Okay, now property is done. We can go to the assembly. Here in the assembly we want to create one instance and we want to duplicate that. So for our convenience, we put this instance type on dependent and we click OK. Now we translate instance. We click on this one, done. This one should be translated to the center. So this is translated. Now we want to create another part and we click OK, but we want to rotate this part and put it here. So first we click on rotate instance and we want to select this one and this edge and we rotate it 180 degrees. As you see here, it's rotated. If it's okay, we click on OK. Now we want to put it here. So the easiest thing to do is to translate it. We click on this one, scroll button. We put this guy here and done. As you see here, we translated the instance right over here. So this is the overlapped region and we have the spot weld in the center, which is pretty great. So assembly section is done. We can go to this step. Here we can create a reference point here in order to see the displacement and force curve, or we can skip that. But here in field output manager we can first we need to create the step. So let's create the step first. It should be dynamic explicit. Yeah, let's put on dynamic explicit, and here the mass scaling, we click this one, use the scaling definitions below and create. We click on this one, 1e -4, and we uncheck this one, then OK and OK. So let's create the reference point. This one is 0, 0, 0, 0, and this one is so this is 15 here. So let's put the value of 0, 100, and for the Z let's say -0.5, and we have this one here. So we accept this value and we create a set here, create a set. Let's name it RP, continue, RP, and done. So we have this reference point. We can use that to tie this surface, couple this surface to this reference point in the future, or we can extract the data. So here in the field output manager, we double check on this one. From the state, we should check on status because we want to simulate this one in a dynamic explicit mode, and we want to see the rupture. So we click on OK. This is a very important one. So the next thing to do is to go to the history output manager. Here we can say set and RP. What we need to see is RF2 and U2. OK, dismiss, and this step is done. Unlike the previous videos, I would like to start with mesh this time. So because we selected the dependent part dependent in the assembly, we should mesh it here with the part. So as you see, this one is yellow. It means it cannot be meshed structured. As you see here, we have X. We cannot have a structured mesh, which is the green part. So we want to fix that. To do so, we would like to go to the partition face sketch. We choose this one and this one, and vertical right, we use this one. First, I would like to create a circle here, and then sweep this circle. We select this one and sweep along the edge. I select this edge in order to have the circle in the other part, and from this one partition face sketch part, let's go to shortest path between 2 points. We select this one, we select this point and this point, and create the partition. We have to do that for other parts. Here, here, and this one. So as we extrude all these lines and edges with this sweep feature, we can have green parts here. It means we can mesh them in structured mode. So sweep along edges, this one. We would like to do that for other edges as well. So this one, sweep along this edge. As you see here, it turned green, so we have to do that for this edge again. Here we have this one and this edge again. Now here they are all turned green. It means we can have a very good mesh here, structured one. So we select this part in order to have the lines extruded in that direction. So here we would like to have defined cutting plane. So we select this one, 3 points, and let's use this one, and this one. So we have these lines here, and we should do that for this part as well. So 3 points, this one, it's not selected. Let's rotate it a little. So this point and this point. We create partition here, this one again. So here, this one, and this one. So we have these lines here in this part and the other side. The last thing to do is to create partition in this side, in the inner circle. So we follow the same procedure to create this partition, and we should do that for this one as well. 3 point. I have to do that once more, right? So this one, 3 point. And that's it. We see here we created all parts and surfaces here, and we created some lines, and we can have a structured mesh. so there should not be a problem. Okay, it's time to create the seed edges. Here we should select this edge and the counterpart. So instead of rotating, which is a time-consuming job, we rotate it a little like this, and by clicking on shift we see we can select different edges. So if I select things like this, and by clicking on control and left click we can uncheck them. So here I click on shift, I can use this, or even I can have the parts like this here in the wireframe mode. It's easier to select this one. So we carefully select this part, this one, these inner circles. I need to select all of them. So everything is selected. We come back to this mode, and yep. So we want to seed edge, so no bias, and by number it should be 4. Let's see how it goes. So if we mesh yet, the mesh is not bad, or we can put this value on 3. It creates a good mesh here in the center. It's acceptable. We can have finer mesh here, but it's totally fine for this tutorial. So the mesh is over, and we have the spot weld here. So we jump back to the interaction. The reason I didn't want to do the interaction first was that if I wanted to create the interactions and I created the parts, the interaction would be eliminated, and I had to do that again. So here we create the constraint. I name it weld, and I want to tie these 2 circles together. So the bottom of this one to the top side of the other part, it should be attached together in order to simulate the spot weld behavior. So I click on tie, and it can be the surface, but I want to eliminate this surface because I want to select the top surface of the bottom plate. From here, create display group, and on cells I can select these cells to be eliminated. We don't remove them, we just hide them. So we hide these cells, we select them, and we can remove them. Also I need to select edit selection, remove this one as well. So selecting this one, this one, this one. See here, I accidentally unselect this one. It's totally fine. I'm just wanted to let you know how it's done. So I'm using this surface to be attached to the other plate. So this is the bottom plate, and the top plate is disappeared. So by clicking on replace all, we just need to eliminate this tiny part here. So we go to the display group again, we edit the selection, we select this one, and this one, and here I click remove. So as you see, this is the bottom plate. I by controlling Shift A, click the bottom plate surface here, as you see. I hope it makes sense for you. So I click done, and I want to choose the slave surface, which is the bottom part of the top plate. I use surface. Again, we go to the we select on this one, replace all, and we go to the display group, edit selection. This time I want to select this one by holding Shift down and remove. So this is the bottom of the top plate, as you see here. This is the bottom of the top plate, is attached to the top surface of the bottom plate. So here we selected both. If it's hard for you guys, you can deselect the whole bottom part in order to have, accurate and more understandable situation. So the next constraint I want to create is coupling. I use this RP1 and the node region. I select this region here and done. So I want to couple this one to the RP point, which is done. Alright, let's go to the load and interaction. Here from the boundary condition, we click on create symmetry. I select the bottom part, which is this one, and I encast. You should move it to left as well. So we encast this part, and we want to have the displacement control on the other part. So I create a displacement rotation. I select RP point. First we click on all of them, make them 0, move them to left. Then we want to have 5mm displacement on this part, and as we have the dynamic explicit model, we should create an amplitude. It should be tabular. We can copy this one with Control C here, Control V here. So this should be 0, 0, 0.1 to 0.1, and 1 to 1, and amplitude 1. Okay, as you see here, we have a displacement control and the arrow facing toward the Y direction. It means it's going to be pulled down that way. So everything is done, but first, before submitting the job, I forgot something. Here we should put this one on part, assign element types, and this one should be explicit. The element types are explicit, and here let's see, if we don't want to see the deleted element, we can have the element deletion here, but we want to see them, so I would use it as is. And let's go to job. Here we create job spot weld TS, short for the tensile shear. Done. I submit the job, monitor. So it means it will initiate the analysis. And the job is completed. Now it's time to go for the results. Here we see the results. Let's see. So yep, here we have. Let's slow down the animation. As you see here, this part is fixed and this part is pulling it. If you see that from this side view, it's more obvious. We can see here it's pulled apart from this zone. Yeah, here some elements are removed and it torn apart from this part, but as you see here, the spot weld is remained intact, and it just, the elements, the rupture happened from this zone, which is called the HAZ zone. Yep. So this is the final state of this one. If you uncheck the status, you cannot see this element deletion and things like that. So the last thing we can do is to create the XY data, and from the ODB history output you can select these two and plot them, and also you can go from this operate on XY data, you can select combine U2 RF2 and plot the force displacement. And that's it. If you enjoyed the video and the tutorial, please like this video, and if you want to see similar contents, please subscribe to the channel. See you in the next video.